And we are live yet again. All right. So, as most of you already know because you heard the janitor when she walked by, apparently those air conditioning units in the hallway are on and off this morning. What happened was actually when I walked by one this morning. Oh, by the way, I think my cord is around the bottom of your desk. Sorry. There we go. Thank you. When I walked by the one down here this morning, that air conditioning unit, I saw it was off and I'm like, oh, let me turn that thing on. So I turned that thing on. But apparently I was not the first one to try that. Apparently you can turn it on and it runs for a short amount of time and then it shuts back down because apparently the tank is full. And then the one down here, the tank is full. So the janitor lady is like, yep, all the tanks are full. So maintenance won't be here for an hour. Great. Okay, cool. In the meantime, I got both windows open and the door trying to get a little bit of a cross breeze. And here we are. One day before the AP test. This is a little practice for when you get into the trailers tomorrow, or the trailer, I should say. I still don't know how exactly they're going to have that. If they're going to have you guys in the main part of the trailer and then the other test, because there's a second test being taken tomorrow in the room adjacent to it. But we'll see what happens because apparently they have thought of everything. My goal for today, number one, I just wanted to give a few words in regards to tomorrow, which I will in a few moments. But then ultimately it's just to low-key review whatever we can today. I'm going to talk a little bit about calculators. I'm going to talk about free response questions. I have things that I'm going to do that I'm going to put up on the board, but we'll talk about that when the time comes. In terms of calculators, I am going to, I forgot who's proctoring your test. I think it was Getty's. Was it Getty's who's proctoring your test? Thanks. Okay, I think so. I hope that's the name I said. But I'm gonna, before you guys leave here today, for those of you that are here, I'm gonna have you be not in command, in possession. I can't think of words today. I'll tell you why in a minute. In possession of your calculator, just to test to see if the batteries are working or not. And then I'm going to make sure that Getty's has the rest. I don't want him to carry over 2 giant bags of calculators plus the test materials. Hold on.
To your teaching and educational process, will all students that are attending the Weird New Jersey field trip please meet us in the front lobby at this time. Thank you and have a Bangorific day.
Bangorific. Yay, Bangorific. So yeah, before we leave here today, I'm going to make sure that you guys have possession of these calculators. And I am going to make sure via the secretaries in the main office that there are extra batteries that they are given to Mr. Getty's for him to bring over as well, just because I'm really trying not to take any chances. I know that they have, paper and pencils and all that stuff over there, over in the trailer. But I don't believe that they have the calculators that we're looking for. So my past 48 hours has been in real life has been a microcosm of this entire year. And I've been thinking about it pretty much all morning. And when I say all morning, I'm saying pretty much since 4 a.m. I've been thinking about what's been going on in my life the past 48 hours and comparing it to what you guys have been going through school-wise in the past 14 months, which, they don't necessarily culminate in tomorrow because tomorrow is the AP stat test. But obviously the school year is coming to an end soon. And for a lot of people, oh yes, and before I forget, I did forget to say it. If you did not leave a comment in the chat, please make sure that you do so. I just saw the one that popped up. I just want to make sure everyone else gets there too. Because your whole lives got disrupted. You guys didn't ask for this. Being in school, in masks, in these little boxes on your desk, virtually, just for however long this has been going on. This school year has not been ideal. My wife yesterday got her second vaccination shot. I think it was Moderna. I'm not sure. But you guys, do you know people who have gotten the second shot who have had pretty negative reactions? Oh yeah, that's my wife this morning. Yeah, that's my wife this morning. She is not doing too well whatsoever, but I didn't know this until literally I'm walking out the door. I literally did not know she was. I mean, I know she had the shot, and we were keeping an eye on symptoms, but I literally didn't know until like, because I'm supposed to be at the door at 6:30. It's like 6:40, and I'm just like, are you gonna be okay? And she's like, I'll be fine. Go. And I'm like, okay, cool. Meanwhile, my son had another sleepwalking episode where he came into the bed around like 11 o'clock. Have I told you guys about my son's sleepwalking episodes? No? Okay. My son has ridiculous sleepwalking episodes, like probably once a month, where he wakes up and he wanders throughout the house having a conversation with himself. It is scary to the point where there was one night where literally he's like sprinting back and forth across the house. And then all of a sudden we hear him trying to jiggle the front door locks. And we're like, holy crap, don't do that. But the thing, you're not supposed to like wake up. No, you're not supposed to do that because that could really be detrimental. Like the idea is you just kind of talk him down and just kind of like, okay, come on, let's lay down in the bed. He's 7. Like, what are you gonna do? So that was around like 11:30 last night. And I got kicked out of the bed mainly because my son decides when he sleeps, he sprawls. So I'm like, okay, I'll go sleep elsewhere. So I slept elsewhere. And then my daughter wakes up and she decides at 3 a.m. that it's dinner time. Yeah. She's just like, I want some dinner. And I'm like, how are you so awake right now? Oh my gosh. So it's been one of those like weird couple of days, and I was thinking about it in terms of like what you guys have gone through. Because like when you go to, when you're planning on going to high school or whatever, you're in middle school, you don't think that your high school careers are going to end with you inside of a little plastic box sitting at your desk with a mask on. That's not what you kind of envisioned it to be. But I don't know. Tomorrow, you're not going to remember how well or how bad you did on the AP test when you're an adult. You're not going to remember that. You're not going to be like, oh yeah, I got a 4. Oh crap, I got a 1 or some junk like that. You're not going to remember that per se, unless, you're an AP stat teacher like me. But tomorrow you do have an opportunity to go in and to give it your best shot and to basically look at this test as if it were the past 14 months. And just literally say to it, screw you, test. I am going to wreck you today. It's something that I've tended to try to do for myself when I was in college, where I would look at a test and I would just have this mentality of, I am going to take this test by the throat and I'm going to strangle it until I get all of the correct answers. I'm not saying that mentality may or may not work for you, but it's an interesting mentality to have. You guys have worked through the most extreme circumstances that a high schooler, has worked through in a long time. I mean, obviously not the most extreme in history. I mean, you've heard stories of guys having to walk 15 miles to get to school or some junk like that. Yeah, people have done that. My grandfather had a second grade education because he had to go to work after second grade. He had to go to work for the family. It's like some people have it rough when it comes to education. But, obviously in recent history, this has just been ridiculous, absolutely ridiculous. But tomorrow you have the opportunity. You have the opportunity to go in. You have the opportunity to do something good. You have the opportunity to kick this test in the teeth. You have an opportunity to those AP graders who they do hate you, mind you. You have an opportunity to prove them wrong. You have an opportunity to outscore more than 40% of the people the students in this country. You have an opportunity to do something good. And that's kind of what I'm hoping for. I mean, how I'm feeling right now personally is pretty much how everyone's been feeling for the past 14 months. I'm exhausted. I'm tired. I'm sweating extra because not only is the air conditioning not working in the school with the windows open and the door open, but I'm in front of the lights right now, which I won't be in a minute. But we can do this. People have been through worse circumstances than this. They have. They really, really have. But we have the opportunity to step up and do something good. Tomorrow, hopefully just to give you a little bit of a reminder as to what you're doing. I don't know if you've already made those plans. I'm assuming those travel plans. You got to be at the place by 11:30. Be there by 11:30. Let's not be late. They're going to start reading the directions at some point between 11:30 and 11:40, I hope, because you should be getting started with the test around noon. So be there. Make sure you've eaten something. It's a 3-hour test, and it's from noon to 3. So pretty much you're not going to have been eaten. You haven't eaten much, unless you, I don't know, you eat like a late lunch. I don't know, but just make sure you've eaten something. I hate that trailer so much. Anyone been in that trailer so far? Yeah, it sucks in that trailer. But those are the circumstances. It kind of caps off this weird year. I don't know. We'll see what happens. We'll see what happens. Okay. Here's my goal for right now. For all of you online and all of you here. I just want to take it very easy today with some free response questions. I'm not going to pass out anything to you, but I am going to ask this. With the questions that I'm about to give you, I would ask that when I give you these questions that you do take a little bit of time and actually write out what your response would be. And then after a certain amount of time, I'm not going to give you like a full 12 minutes or something like that. But after a certain amount of time, I would like to then have that discussion. So with whatever you're writing these things on, preferably I would suggest your notebooks because there's going to be a lot of writing tomorrow during the free response section. If you would, please have those notebooks out and open. Oh, goodness. I learned that my daughter, despite the fact that she has my genes, tans quite easily. And I do not. Now, I did not plan on rolling up my sleeves today, but it is so stinking hot in here. But you can see I'm like a little red today. I was at the beach on Saturday for a couple hours in the morning for a memorial service. And I remember I lathered up. I did whatever I had to do, blah, 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 sunscreen, because I burned like crazy. I forgot one place to put my sunscreen on the tops of my head because I got a little bald patch up here. And that hurts every time I do that. Just saying. I shouldn't do that. Anyway, back to this. Okay. After a couple of questions, I want to talk about those calculators some more. Oh, I want to do this first. Okay. You don't have to look at your computers right now. But I am gonna post it to the Google Classroom. Just something fun. I may have read this to you before. I've read to you the AP Stat Prayer? Did I not tell you about the AP Stat Prayer? This is perfect. Because I thought I had done it too soon. I thought I did it too soon. I always do it like the day before the test or the day of the test, whatever. But there's the AP Stat Prayer. What happened was about 6 years ago maybe, I had a class, AP Stat. I had 5 kids in the class, 5 total. And because there were 5 total kids and because we were actually allowed to communicate with each other in groups, they actually had a pretty good camaraderie. So together with this one main guy, John, he came up with what he called the AP Stat Prayer. And basically probably around like January, February, when we were actually taking tests in class, before they actually took the test, he memorized the prayer and he and another student would actually recite it out loud for the whole class to hear before they took the test. And it just became like this thing for them to do. And I thought, that's cool. That's their thing. You know, like, I'm not going to steal their thing. I'm not going to be like, let's make it our thing. Like, no, you guys have your own thing. But every year before the AP Stat test, I do tend to post this for funsies because I just think it's a really cool thing. But he wrote this about 5 or 6 years ago, this kid named John. He has obviously since graduated. I believe he's graduated college or whatnot. But he wrote this, and again, he memorized this. It says, AP Statistics God who art in quartile, hallowed be thy sampling. The linear regression shall be done, always with diagnostics on. Give us this day our normal distribution and forgive us our rounding error, as we forgive those who don't know probability. Lead us not into extrapolation, but deliver us from bias. Median. I just thought, I'm like, that is something else. That is ridiculously something else. So I post that on the Google Classroom for you all, just kind of as a, people have been through it before, people who've been through it since. It's just kind of a fun little thing. I don't know. So when Twitter was a thing, I would post it on there. Is Twitter still a thing? I'm sorry, let me rephrase. Is Twitter still a popular thing? You're saying, yeah, okay, all right, whatever. Back to this. So that's on the Google Classroom stream for you, just for funsies. But I'm going to go here. And let's start with something like this. I like this one. Okay. Oh, where are you? Frozen? Yeah, you're frozen. There you go. Zooming in. So what I'm going to do is this. I'm going to read it, and then I'm going to give you guys a certain amount of time to do whatever you need to do to answer said question. Write down how you would respond. Write down the work that you would show. Obviously, some of it would just be like functional calculations in the calculator. Suppose that jumps by Olympic men high jumpers have a normal distribution with mean 2.12 meters and standard deviation of 0.12 meters. Women's jumps have a normal distribution of 1.8 meters and a standard deviation of 0.09 meters. A man and women Olympic high jumper are picked at random. What is the probability the sum of their jumps is over 4 meters? And what is the probability that the man jumped higher than the woman? I want you to treat this like this is the actual question. You're going to write down what you would respond for the free response on the actual test. That would be wonderful. And I will give you a limited amount of time to kind of get that done. Let's see what we do. I'll just lower it in one moment. It's gonna finish. This is the first question. Actually, see this one. There's no air conditioning for the next hour. I know. I know. That's why I have one Basically, I think you guys a limited amount of time, probably, maybe a couple of minutes. And then have you guys treat it like a free response in the AP test. And I'll see how much of that. And a little speech at the beginning, great, people cried. There were tears, but I come from the heat. I also posted the AP stat prayer. The Google Classroom. Have you ever seen that? Okay. When you get the chance. Yeah. The interesting thing about these questions is I'm not actually looking at the back of the card before I choose most of them. I'm just kind of like skimming the card and being like, will this one be a good one? Is this the type of question that they may throw at them? And yes, this is probably the type of question that they would throw at them. Probably question 2 or 3 on the free response. Usually the first question is a little bit longer, but kind of older information. And then the second or third one of them has to do with probability, and it's usually short like this. And then they get into the deeper ones, which I have one lined up for that. Well, let's see what we got here. They tell you it's a normal distribution, which is golden. The fact that they tell you that, that's cool. And they tell you that men have a mean of 212 and a standard deviation of 0.12. There's no sample that they speak of, so I'm just going to assume the mean of the men is 2.12, and the standard deviation of the men is 0.12 in the proper population parameter notation. Whereas women also normally distributed 1.8 with a standard deviation of 0.09. It's good to identify that you understand the proper notation for those materials. And then they have them being picked at random. Okay. What is the probability that the sum of their jumps is over 4 meters? You're combining a randomly picked man and a randomly picked woman. One assumption that you can make is obviously that the randomly picked man and woman, their jumps, their high jumps, their high jumps are independent of each other. That is reasonable that they're independent of each other. So if you wanted to do a combined mean right there, it's just a matter of adding them together. What is that? 3.92. They're talking about the sum of their combined jumps. Now that just is an average. Their combined average jumps is 3.92. Yes, they're looking for the probability of them being over 4 meters, but I am going to have to combine their standard deviations. But in order to combine their standard deviations and the fact that they are independent of each other reasonably, we're going to do a combined standard deviation, square them to variance, add them together, square root them back. I don't know what that number is at the moment. I'll look up that number later. But that would be the combined standard deviations. And I'm not going to worry about part B right now. I'll come back to part B. But just for part A, if you're going to knock out part A, good way of doing this, normal CDF, 4 comma some big number, comma 3.92, comma whatever this decimal is, which I don't know. Don't know what the decimal was off the top of my head. I don't know who would. That is ridiculous. Square root that sucker. Yeah. Square root that sucker. Oh, wow. For real? That's a nice number. It's literally 0.15 right on the dot. That's a really nice number. They probably did that on purpose. If you do the normal CDF with those numbers, comma 3.92, comma 0.15, boom, should be about 0.2969, so 0.297. It should be 0.297. You could leave it like that. You can leave it as a decimal. You could turn it into a percentage if you wanted to, but that is the probability that the sum of their jumps is over 4. But then for part B, they want to know, what is the probability that the man jumped higher than the woman? Theoretically, the average male high jump is higher than that of the average female high jump. But now what is the probability that a randomly selected man who would follow those statistics and a randomly selected woman, if that the man jumped higher than the woman? Get rid of that. And get rid of that. And I'm changing that to a D. I'm changing it to a D because I want the difference. I want to find the difference between them. The difference between them, if I were to do that calculation, 2.12 minus 1.8 gives me 0.32. The average difference between them is 0.32 meters. Fantastic. Now, I made a show of erasing that sigma. And then now we have to find the difference between those two standard deviations. But hopefully you remember the phrase, not a typo. It's not a typo. It is not a typo for me to do this. 0.12 squared plus 0.09 squared, square root that thing back. It's not a typo. Because even if you were finding the difference between them, you were still going to add those standard deviations together once you convert them to variance. The next small little hurdle to get over is figuring out what goes in for the limits, lower limit, upper limit. They want to know the probability that the man jumped higher. They're looking at the difference between man minus woman. So if they're doing man minus woman, I'm going to go 0, comma, big number. Because if I go 0, comma, big number, it's going to give me the limits of basically no difference to all of the positive differences when you do man minus woman. If I did that calculation correctly, 0.32, comma, 0.15, boom, 0.984. If you randomly select a man and a woman, there's about a 98.4% chance that the man would jump higher than the woman. Not a guarantee, but obviously this is getting in the way right here. I did not draw those block letters. Now for a problem like this, what work would you have to show? You don't have to show a lot of work, but you should be showing this normal CDF. You should be showing the numbers that you had on the inside. That would be sufficient. You should be showing this form of calculation right here equaling 0.15. As long as you show them what you did on the calculator, that should be sufficient. And that will be sufficient. People in my hallway making noise. But yeah, that would be, if you showed all of that work, what I just did, that's a 4 right there. 4 out of 4 on that free response. Okay. I have a challenge for you, small challenge. This one's going to take a little bit longer. Like I said, I would like you to write out the response as if you were actually taking this particular AP test. This one's going to take a little bit of reading. I'm going to read it with you, especially for those that are online. Let me zoom out just a tiny bit. But this is a quintessential free response question. So, again, for those of you online, I'm going to read it carefully so that you have the proper information. Again, I do realize there is a little bit of glare in the middle. A company advertises that it has a process that can extract 5 kilograms of protein from 100 kilograms of seaweed. Using this process, A random sample of 15 100 kilogram clumps of seaweed yields a mean of 4.82 kilograms of protein with a standard deviation of 0.65 kilograms. Just as a side note, the questions that you're going to be seeing tomorrow are going to be equally ridiculous in their premise. The premise of some of these questions are going to be ridiculous, as you've seen in the past. Assume the sample distribution is symmetric, unimodal, no outliers. Is there sufficient evidence to dispute the advertisement, justify your answer? That's a huge part of this problem that will take up a bulk of your work. But then it goes on. A large-scale test of a second company's process shows yields of protein that are normally distributed with a mean of 4.75 kilograms and a standard deviation of 0.83 kilograms. So now this is not a separate problem, but you would not use this information for part A. You would not use this information for part A. But then part B, what is the probability that using the second process, a 100 kilogram clump of seaweed will yield at least 5 kilograms of protein? And then what is the probability that using the second process on 10 randomly selected 100 kilogram clumps of seaweed, at least 2 of them yield at least 5 kilograms of protein? This is a ridiculous question, but I am going to give you slightly more time on this one. Take your time. Read it again if you need to. Ask for clarification if you can't see one of these numbers. Let's go. I know some of you are wrapping this up, but I wanted to talk about, before I even begin answering it, I wanted to talk about what the expectations are for this particular question. The second that you read, is there sufficient evidence? What should be going through your mind is, well, I got to create a hypothesis test. I'm going to have to write out the hypotheses, assumptions and conditions, perform the test, proper conclusion. That's what we've been prepping for all year. Well, not all year, but from the time we introduced hypothesis testing in general. Now, that's just for part A. Part B and C, I'll get to them later because they do require slightly different things. But let's talk about what we have to do for part A. Now, I'm actually going to write some of this out for myself because it's easier than trying to jot everything out on the board. Let's see what I get here. It says a company advertises it has a process that can extract 5 kilograms of protein from 100 kilograms of seaweed. That's their claim. They are claiming that they can do such a thing. Then there's a random sample. So hold on. Let me just jot down a couple of things. Maybe this could potentially be helpful. It sounds to me like when it comes to their null hypothesis, this is what their claim would be. They're claiming that they can actually do this. But now there's a random sample of 15, n equals 15, 100 kilogram clumps of seaweed that has a different mean. It has an X bar, mean of 4.82 with an n equal 15. Standard deviation of 0.65. So this is the information that I just jotted down. That's an X bar, 4.82, a sample size of 15, a sample standard deviation of 0.65. Assume the sample symmetric, unimodal, no outliers. Is there sufficient evidence to dispute the advertisement? Well, because they worded it like that, is there sufficient evidence to dispute the advertisement? I am going to put my alternative hypothesis like that. Mr. Markey, you kind of set that up a little bit where disputing it, we thought you would do not equals to. Well, if they claim 5 kilograms and it turns out that it's actually like 5.2, the company doesn't look too worse. The company looks better. If they do more, if they extract more protein than 5 kilograms, good for them. I'm disputing the claim saying that, no, it's not that large. It's not that high. It's going the other direction because you're trying to dispute their claim. If you say not equal to, then it's just like, well, they could then say, well, then it could be more than 5. No, I'm disputing it in the other direction. Those are my null and alternate hypotheses using mu. Not only that, look at the other information that they gave me. They gave me an X bar, an N, and a sample standard deviation. They did not give me a population standard deviation. Because I have quantitative data, because they did not give me a population standard deviation, it seems like I'm going to be running a t-test here. It seems like I'm going to be running a t-test here. Yeah. Not only that, the sample size doesn't seem large enough. It's not. It doesn't seem large enough. So, I mean, it'd be kind of hard running a z-test here. So I got to go with t, especially without that population standard deviation. So let me read the card one more time because I got to go through some assumptions and conditions. I just wrote up my hypotheses. Now I got to do some assumptions and conditions. Okay. I mean, 15 clumps seems less than 10% of all possible clumps. That seems sufficient. Absolutely. They did say random sample. Random sample stated. It's literally stated in the problem, a random sample of 15 bags or 15 clumps. it's reasonable then, independence of, let's call it, I don't want to call them just clumps though. Clumps of seaweed. Independence of protein extracted. That's probably a good one. Reasonable. Yeah. Independence of protein extracted. I'm trying to give it some kind of a context within the problem. You really should be putting these things within the context of the problem. And finally, nearly normal. Now, you don't know what the graph, like you haven't actually seen their data, but nearly normal met because symmetric / unimodal, no outliers. I'll show you what I wrote down right here in a moment. Boom, let me zoom out a little. Here's what I wrote down. What I wrote down was 15 clumps or less than 10% of all possible clumps. I mean, I guess I'm going to assume that they could, eventually take like 150 or more clumps of seaweed. Cool. They probably will. Random samples stated within the problem. Independence of protein extracted is reasonable, especially from clump to clump. And nearly normal is actually met because the problem describes itself as symmetric unimodal with no outliers. In conclusion, I'm going to be doing a one sample t-test. So I'm going to go to my calculator and actually type in some of this information. Let's see here. Don't just give me a checklist of assumptions and conditions. Actually give it context. Stat, tests, t-test. I'm going to go to stats again right here. Here we go. I'm going to type in this appropriate information. They claim 5. The sample that I was given. The sample standard deviation. The sample size. My alternate hypothesis. Just double checking, making sure all of those numbers are correct. Yes, indeed, they are from what I've written down. Let's calculate this sucker. Oh, interesting. I mean, it's a low p-value, but it's not low enough. Okay. So let me write. Now, I've already written down X bar, N, and S. I've written down all that stuff already, so I'm going to write down a T score, I should say, or the T statistic is equal to negative 1.07. And my p-value is 0.151. That seems sufficient. Let me zoom out a little. There's my t-score and my p-value. That was calculated using that one sample t-test, which I was justified in using by those assumptions and conditions. They don't specifically say, hey, use an alpha level of 0.05. You're going to assume an alpha level of 0.05. And clearly, the p-value is not low enough. It is not low enough. We have to fail to reject. You have to fail to reject. Now, I could argue here, well, I'm going to fail to reject. There's not enough evidence. You could also argue, I'm going to fail to reject even though there is some evidence, because the p-value is low. It's just not low enough. But I'm going to write it out as not enough evidence. So I would write, let me get my card here, put it in context. I would say with a p-value not low enough, parentheses 0.151 is greater than 0.05, with the p-value not low enough, we fail to reject the null. There is not enough evidence, and I'm going to put this within the context of the problem. There is not enough evidence to dispute the advertisement, put it in the context of the question that they literally asked. There is not enough evidence to dispute the advertisement of claiming to extract 5 kilograms of protein from 100 kilogram seaweed, or from 100 kilograms of seaweed. Seaweed is gross. It just is. But yeah, with a p-value that low, I'm sorry, that p-value not low enough, I should say, we are going to fail to reject. There's not enough evidence to dispute the advertisement of claiming to extract 5 kilograms of protein from 100 kilograms of seaweed. I wrote 100 kilograms, and it looks like the word look. I don't like it when it does that. Kg. Why didn't I just put kg? Kg, kilograms. There we go. Now it looks better. Now, mind you, that was only part of the question. They wanted you to run that hypothesis test, which they gave you all of that information. You came to that conclusion, but now they're giving you additional information. This is the type of free response that they would give you probably as question number 4 or 5. 4 or 5. They would not give this to you as the extended constructed response. They would give this to you question 4 or 5. Something along those lines. Let me read what else they gave us. Focus. Here we go. A large-scale test of a second company's process shows yields of protein that are normally distributed. They actually tell you that, with a mean of 4.75 and a standard deviation of 0.83. Okay, so new problem-ish. New problem-ish. Here we go. For part B, now they're telling us that they have a process at 4.75 kilograms with standard deviation of 0.83. In part B, they actually tell you the population standard deviation. You can't use that for part A. You can only use that for part B. Then they ask the question, what is the probability that using this second process, that 100 kilogram clump will yield at least 5 kilograms of protein? Well, they want a probability. They tell me it's normally distributed. Since they're telling me it's normally distributed, that's a huge indicator that I'm just going to jump straight to normal CDF. At least 5 kilograms, 5 or more, 5 comma big number. 4.75 is my mean. Yeah, it's just going to be 0.83. There's no sample being taken for part B. There's no sample being taken. Just 0.83. If there were a sample taken, if this were a sample distribution, then I would have to divide that standard deviation by the square root of the sample size. But no, not here. They're just saying, like, okay, what's just the probability that the second process would just yield at least 5 kilograms of protein? All right. Just see what the thing says here. Normal CDF, 5 comma big number, comma 4.75, comma 0.83. Boom. Should be approximately 0.382. That's all you literally had to do for part B. I identified a new mu and a new sigma. And based on the wording of the problem, based on the fact that they told me it was normally distributed, I can use normal CDF. It's not a sample. They just want to know straight up what's the probability of this happening. But then part C. Ooh, part C. I'm going to zoom in on part C in a moment. But part C does take us in a weird direction. Let me zoom in here. At this point, if you were able to answer part A and B correctly on the AP test, if you were able to do that correctly on the AP test, that probably gets you maybe, at the very least, like a 3 out of 4, something like that. Definitely a 3 out of 4. So if you left C blank, they'd probably still keep it at the 3 out of 4, maybe bringing it down to a 2 because sometimes they have the discretion to do so. Part C. What is the probability that using this second process on 10 randomly selected 100 kilogram clumps of seaweed, at least 2 of them yield at least 5 kilograms of protein. Huh. There's a couple ways of handling this problem. What is the probability that a 10 randomly selected, n equals 10, at least 2, so at least 2 have at least 5 kilograms? This is what they really want to know right here for part C. Same information, second process, meaning a mu of 4.75 and a sigma of 0.83. Oh, zooming out. Look at that sample size. There's a couple different ways to handle this problem. There are a couple different ways. I'm going to show you the way that you should handle it, and then I'm going to show you a backup way where you could handle it. But here's what you could do. Let's say, oh, interesting. Okay. Question. Can you have, I'm going to read this question once I zoom in on this. They want to know if at least 2 of them yield the successful amount of kilograms of protein. Can I have 2.5 successes? Could I have a situation where I have 2 bags meet the criteria and then half a bag meet the criteria? Hey, you're shaking your head. That sounds ridiculous. It sounds ridiculous. How could you have half of the bag meet the criteria? It's like, no, either the bag meets the criteria or it doesn't. Either you successfully extracted 5 kilograms of protein from the seaweed. It's a weird sentence to say, but either you've done that or you haven't. This problem, part C, the way that it is described is either each bag is a success or a failure. That's all that it comes down to. Because of the way that part C is described, you have a finite number of trials. You either have success or failure. You have a certain probability of success within each bag, which you found that probability of success in the previous part. This is a binomial problem. This is a binomial problem. Now, like I said, I'm going to show you how you should handle it, and then I'm going to show you a backup strategy. A backup strategy. Here's how you should handle it. Binomial CDF 10, comma, 0.382, comma, 1, parentheses. Now, I did that on purpose. I'm going to add something else to the front of this in a moment. This is a reminder. Out of 10 bags, these are all of the possibilities of success. They want to know, okay, what's the probability of getting at least 2, meaning 2 or more successes. But as we know, binomial CDF does or less, not or more. So you're going to have to calculate 1 or less and then do a 1 minus in order to get that thing done correctly. You're going to have to do a 1 minus to get that thing done correctly. Let's see what it looks like. Aha. 1 minus. Let's see here. That's not us. Binomial CDF. Again, how have they not fixed the bells? Like, anyway, sorry. 1 minus. Hold on.
Anthony Burton, please come to the main office. Anthony Burton, please come to the main office.
10, comma, 0.382, comma, 1. Chapow. There's your answer. There is the sufficient answer to the end of this question. It should be approximately 0.941 or, 0.941 approximately. 0.942 really, but you can go with either or. Now, that's the way that you should handle this problem. That is the way that you should handle calculating this problem. But I did want to show you a backup strategy. The backup strategy would be using normal CDF, but you really do have to be careful. You could use normal CDF, but you have to be careful because the answer is not going to be exact. And the reason it's not going to be exact is because you are dealing with only 10 trials. The definition that I gave you a long time ago about binomial distributions is that a binomial distribution will become more normal as long as the sample size is large enough, or as it grows larger, it's going to become more normal. So this is only a backup strategy because you really should be doing the binomial as your first choice, which that is the correct answer to this problem. We got that 0.382. Let me zoom out. We got that 0.382 from the previous part. That was the probability of success. But now you could do something like this. But again, this answer is not going to be exact. Normal CDF. They want to know at least 2 of them yielding at least 5 kilograms. Again, it's a silly kind of thing to do, comma. 2 or more. 4.75. I might change that big number in a minute. 4.75 is that's the amount right there. How would I even do that? No, I would do this. 10 times 0.382. That's what I would do there. Again, I don't even want to write this down, but 10 times 0.382, that's the probability of success. That is the probability of success times the number of trials times the square root of 10 times 0.382 times 1 minus 0.382. This is just a backup strategy. The answer is not exact. They might give you partial credit if you did something like that. Yeah, they might give you partial credit if you did something like that, but they would not give you full credit. Because in order to get that full credit, you would have had to recognize the fact that, well, the sample's not large enough to do a normal CDF. You would have to rely on a binomial with that's 10 trials, and that's the most straightforward way to get it done. Oh, this problem. Okay. Here's a short one. And I will tell you one thing after I bring this question up. I will remind you of one thing. You need to remember how to cuss. You need to remember how to cuss. The GPAs of random samples of 50 males and 50 female students at a large university are noted and summarized at the right. Write a few sentences comparing the distributions of GPAs of male and female students at this university. I'm only going to give you a couple of minutes or less because this is a short question. Very short. This would probably only be like one part of a free response question. Let's see what you write. as I said, in terms of remembering how to cuss, cuss was describing the distribution of graphical display, center, unusual features, shape, and spread. Let's start with the easiest, shape. Shape is the absolute easiest. You could say that the male histogram looks more normal. It's definitely bell-shaped. It's definitely unimodal and unimodal and symmetric, and close to being symmetric. But you could say it's nearly normal. The female distribution, on the other hand, is skewed. But the question is skewed in what direction? Because they would expect some kind of a direction for you to be able to skew this thing, and it is skewed towards the tail. It is skewed to the left. It is skewed to the left. Now, in terms of spread, they don't tell you how many people are in this histogram. They don't tell you what the quartiles are. You can't identify an IQR. You can't identify a standard deviation. So you're going to have to rely on some other measure of spread. And since you can't do interquartile range, you could still technically do range. And that would be the best that you can do in terms of identifying what spread is. In terms of spread, you could say that the males go from 0.5 to 3.5, give or take. So you could say that their spread is 3, whereas the females go from 1 to 4. So actually, no, they have the same kind of range. They have the same range, approximately 3. Now, I would say approximately. I wouldn't say that it is, because you don't know if those numbers, you don't know if it's like 3.9 or 3.7 that kind of round up for the females, or if it's like a 0.75 that round down for the males. Something along those lines. In terms of center, well, for the males, it's easy to get the center. The center is approximately between 2 and 2.5. It's approximately between 2 and 2.5. Whereas for the females, now this is a bit dicier because you don't know, you know what's happened to their center. Because it's skewed to the left, the center of the females has been taken from that peak of 3 to 3.5, and it's actually been pulled down a little bit. It's been pulled down a little bit because of that skew. So, I mean, you could reasonably say that the female center has been pulled down below that peak of 3 to 3.5, perhaps down as low as 2.5. It's speculating. And even though there aren't any, it would always be in your best interest to be complete and say that there do not appear to be any outliers. Again, fluffy language. There do not appear to be any outliers. There do not seem to be any outliers. Don't just flat out say there aren't any, because you don't know. You don't know if there are or there aren't. The only thing you can say is there doesn't appear to be any. That's the best that you can do for that problem. Okay. I do like that problem. Or no, the problem I was just looking at. Oh, that's a good one. I'm going to do that one instead. Okay. Taking this one away. This one right here. This is exactly the type of problem they would give you for like a number 1. Short, kind of. Not necessarily earlier information, but it is short. But it does ask for a lot. A university recruiter claims that 60% of its basketball and football players graduate in 4 years. A reporter contacts a simple random sample of players from the past 20 years and finds out that only 46 out of 88 had graduated in 4 years, which, for the sake of argument, 46 out of 88 is about 52%. It's about 52.3%. Obviously, you can calculate that on your own, but he found a simple random sample of players that were less than the claim of 60%. Is there sufficient evidence to write an article disputing the university claim? Give statistical justification for your conclusion. Now, for the sake of time, I am going to give you a limited amount of time to get this done, but I will tell you that you obviously have to be running a hypothesis test. See what you can do. I'll give you the next little block of time. Okay. Let me just verbally talk about what is expected on this problem. Again, for the sake of time, because I do want to make sure that we talk about the calculators a little bit more before you leave. This problem requires a hypothesis test. And because you're dealing with categorical data, because you're dealing with proportions, obviously you're going to be wanting to run a proportion z-test. You're going to be doing a prop z-test of some sort with this problem. In terms of your hypotheses, again, I'll do one of those things where I kind of write it out just a little bit. But this is the way that your hypotheses should be shaping up. They should be shaped up like that. Number one, you should be using P for proportions. Number two, the claim is 60%, but now you have evidence disputing the 60%. It's actually less than the 60%. But again, you wouldn't do not equals to, because if it ends up being 65%, then the guy looks better than what he actually claimed. You're trying to claim the opposite direction. You're saying he's not being truthful, or maybe he's, inflating the numbers a little bit. So the alternate has to be less than in that case. You got to make sure you hit the assumptions and conditions. Number one, simple random sample. Because it's a simple random sample, it's reasonable to assume that whether or not a student graduates is independent of the next. That's reasonable because of the randomness. The sample size of 88 is large enough. Not only is the sample size of 88 large enough, but you also need to be doing this. Because there is a claimed number, you're going to want to look at the expected successes and the expected failures to make sure that they're more than 10. You have to have at least 10 in each direction, which clearly we do. Not only that, you could say that 88. Well, you could say 88. Yeah, we're looking at a sample size of 88. You could say that 88 is less than 10% of basketball and football players that had attended the school within the last 20 years. Definitely make sure you hit that 10% rule. But you're going to be hitting a one proportion z-test. A one proportion z-test, which I've already run over here. But I want to show you what I typed in. That's all that I typed in. Let me draw this thing out just for the fun of it. There it is. But you can see that p-value. Now here's the deal. Think about this logically. Think about this as if it were real life. Think about this as if you're thinking from the perspective of the recruiter, and you're thinking about it from the perspective of was it a newspaper? Yeah, it was a reporter. From the reporter's point of view, the reporter's like, I really want to dispute this guy's claim. Okay, well, my alpha level was 0.10, and clearly 0.10 is greater than 0.069, so I can reject on that basis and now write my article saying that the recruiter's not telling the truth. Whereas the recruiter would then look at it from the perspective of, no, 0.069 is clearly greater than 0.05, alpha level, what have you. It's weird to think. Again, the alpha level has not been set. Is there overwhelming evidence that the 60% claim is wrong? No, it's not overwhelming evidence. There's some evidence. If you're the reporter, you may want it to land one way. If you are the recruiter, you may want it to land the other way. As someone in the middle, as an objective stat person, you can say, I fail to reject. I fail to reject here. There's not enough evidence to suggest. Oh, no, not there. I'm sorry. Not fail to reject there. Fail to reject here. Here we go. You would fail to reject here because it is not low enough. Not enough evidence. It's close, but it's not. But if you wanted to write the conclusion as rejecting, you technically could. You could say it's low enough up here, the p-value being low enough if you wanted to, and then you just write out that conclusion. You'd be right either way. But you would have to back up what p-value you used. If the p is low, the hoe must go. Okay. Here's what I need you to do. I'm done for this day. I have contacted Mr. Geddes. I was emailing him during this class period. And he said that he would have no problem taking the calculators off my hands and bringing them tomorrow so you guys wouldn't have to be responsible for them. So he confirmed that for me, so I don't have to hand them out to you. What I am going to do is I'm going to go through every single calculator. I'll make sure my hands are sanitized beforehand, but I will go through every single calculator and I will personally confirm that the batteries are good to go. I will secure extra batteries to give to Mr. Geddes as a just in case. And I will be going down to the media center and I will be securing extra calculators as a backup just in case as well, because you never know what might happen. I'm going to try and post something on Google Classroom for you guys, just kind of as a final message. Unfortunately, they were not able to get coverage per se, because you guys, your test is at 11:30 noon. I have a class during that time, so they can't let me go or can't find a sub to cover my class. I'm going to try to bug them again for it, but we'll see. So if I don't see you tomorrow, good luck, and take that test by the throat. That's all I got to say. That bell's going to ring in like 1 second or so. Nailed it. If you haven't left a comment in the chat, please make sure that you do so. I'll leave it open for another moment.
TJ Stouts, please report to attendance. You have permission to sign out.